each of these heat exchangers, HX1, HX2, they are both brine ammonia heat exchangers, and what they're doing is they're taking the heat that is put into the ice. So the heat goes into the ice every time you do a flood, and it removes the heat from the ice using the brine that gets circulated through the floor. So each of these floors has got a whole series of brine lines running through them. There's a supply header and a return header, and the pumps, which you can see on this piping diagram here. So these pumps, shown here, here, circulate the brine through the floors and through the heat exchangers. So as the brine circulates through the floor, it absorbs the heat that goes into the ice when you do a flood. No matter how hard your plant is working, it doesn't matter how big the pumps are, how many tons of refrigeration you have, there is still a limit to how quickly that heat can be absorbed and removed. It's just laws of physics. I mean, bigger plant, bigger pumps, yes, you can remove more heat, but there is a limit on how fast it can happen. So here we've got our 3 brine pumps. When you're looking at the brine pumps, you should easily be able to tell which one is for which arena. So if you look at them, you can see there's a difference in size. This biggest one here is for the AK arena because it is the furthest away in terms of the amount of GPM that are flowing. So the curling rink is fairly far, but it has a lot less brine lines in it, and it has a lot less brine flowing through it. So therefore it's a much smaller motor. The AK arena has got a lot of brine flowing through it, and it's quite far away, so it's a large motor. The TC arena is kind of in the middle. It's close, but it has a lot of brine flowing through it, so it's a lot bigger than the curling, but a bit smaller than the AK arena. So if you look at the labels, P102, that's AK, P104, that's curling, P101, that's TC. The curling rink always needs to run in coordination with one of the other 2 arenas. Right now, it is set up to run with the curling rink. The reason for that is the curling rink doesn't have enough heat load to run the compressors by itself, so it gets its cooling from the floor that it's paired with. If you look at the piping here, you can see that that's closed, and back there that's closed. That means that this side is running in coordination together and sharing a common brine tank. So the brine tanks, there's heat floor and then the 2 cold floors, and those 2 cold floors are the balance tanks, and the curling rink can kind of go with either one. When it needs to be changed, it needs to be changed both via the valves and in the computer system. So that's something that you should always make sure you have someone who really knows what they're doing change that. It's important that it's done correctly in order to keep things working properly. So the curling floor can never run by itself. It always has to run with one of the other 2 floors, and currently it's set up with the TC arena. So back to where the heat's going. So as the pumps circulate the brine through the floors, the pumps are bringing the brine in, and it's taking the brine that has picked up the heat from the arena floors, and it's bringing it in here. And so this is an ammonia brine heat exchanger, and you can see it's coming in here where it's labeled inlet, so that's your in to your heat exchanger. Down here, outlet is out of the heat exchanger. You can see here that it's calcium chloride at 21% concentration, and that has your heat from your brine going into your ammonia. So as the ammonia is boiled off by the low pressure state that's created by the compressors when they apply suction to it, it's taking the heat from the brine and transferring that heat into the ammonia. In the video on ammonia, I covered how that heat is getting moved through the compressors and where it's giving up its heat to the glycol in the condenser. The one thing that you should probably make sure that you are aware of and pay attention to is, so these balance tanks for the brine systems, there's 2 of them, and they go with the 2 heat exchangers. So we've got HX1, HX2, each of them have their own brine tank. It's going to be set up that that's going to be the way they normally run. In an emergency, it can be run in a way that they share a common system, but that's something we want to avoid doing unless we have to. That's only something we're going to do short term if a motor goes down, and again, that's something that it needs to be somebody who is really certain of what they're doing to do that switch over. On the balance tanks, it's going to be important to maintain a higher level than you might otherwise think. So when you look at that balance tank up there, it looks, it looks more than half full. It looks like it's got lots of brine in it. But really, if you look at how high the top of these lines are, these lines sit up quite high relative to the balance tanks. So if your balance tank's too low, you could actually be down below the level of these lines and think that you're still okay. So we're going to mark what sort of the safe line is on those tanks. Now, after the brine gives up its heat to the ammonia, it is circulated out back to the floors, picks up more heat, and just keeps that constant loop going. Once the floors have had enough heat removed, then the brine pumps are going to shut off because they're no longer being called for. All of that is what you're going to see over here on this computer screen. You'll have these spinning when the pumps are running, and you'll also be able to see when the compressors are running based on these turning green when they're being called for. That pretty much covers the cool floor brine system. In terms of labeling, you can see that there's labels out here. They couldn't really wrap the pipes in them because of the size of the labels, but if you just trace them back, you'll be able to figure out which is which. The easy way to tell is with these pumps, the part going out of the top of the pump is the supply. The part going into the pump is the return. All of your temperatures can be found fairly close to the pumps, and all of your pressures are found just off the volutes of the pumps. All right, that should cover everything for the cold floor brine system. I guess the other thing I could add is that these VFDs control the speed at which the motors for the brine pumps run at.